Hello everyone. So this is the second video of my ongoing project, and I would like to show you the uh, progress of this project till now. It had been quite a few days since I had done any progress in the project, but I would like to show you how much did I implement till now. So, majorly this project is related to secure communication channel over a LAN network. That would be a local area network. It would be a Wi-Fi or anything similar to that. The model that I have opted for is a client-server model in which there would be a server and multiple clients can connect to that. And right now the progress is like this. So I have a server and multiple clients can connect to that server if they have the IP and the port, and they can communicate with each other. If any client sends a message, the server right now broadcasts the message to all other clients except the sender. So uh, let me show you the working first, and then we could see the code. So this is my project directory. I have client code and server code, and I am using Golang for this project. So it would be very good to know and connect with the, you can say, what are those things, concurrency and error handling, for those principles, and obviously the simplest syntax and a close relationship with C. I had preferred this language. First, let me run these files and I can show you. So I am first going to run a server. So the server is up, and the server is at you can see 127.0.1 point, 9000 port, that is a 9000 port, and it is connected to localhost. Let me start a client then. So a client has started and it's also connected to a server, you can see in here, and there are some few metadatas. As you can see, the client is connected at from 61112, and right now I have only one client, so let me connect another one, and there is another client, you can see in the server part. We now have two clients. So let me try to send a message from client 1. So client 1 sent a message hi, and we received the same message hi in the message body in the another client. So let's get one more client. So we can see that we have now connected three clients, and let me try to send some message from the client 2. Hello. So we received it in client 1, hello, and we received it in client 3 as well, hello. So what is happening here is one client sent some message, it is converted into an object, then passed into a JSON, and then it is sent over the communication channel, and that is TCP. We are using here TCP communication. So that was the simplest one I have opted for. So in future we could implement some other, since I am trying to make it a modular project in which we could just tweak some things, and overall project will work. So in here, one client sends a message passed into a JSON, and then all other client received the broadcasted message from the server itself. So let me show you how I have implemented till now. Right now I have only implemented these in two files, and no segregation of you can say types and protocols and all those things. My next phase is to implement the segregation. I would uh, break down these codes into multiple files, each with its own properties, so the project can be a modular one. So let me show you the server one. So let's start from the main entry point. So I have made a TCP listener at port 9000 at localhost, and one of the best thing of Golang is the you can say explicit error handling, and we handle all the errors right then and there wherever it is generated. So we started a listener at port 9000 and handle the error. If the server has failed to start, then there is no need to continue the code. So we panic and return the errors. And also we defer. Defer is a thing that would help us close the listener whenever the uh, main entry point closes. So we don't have to close the listener at bottom, and that is why we have used defer. As the function exits, the listener will automatically be closed, and then we are accepting clients in infinite loops. So right now it is a simple client server model where there is a one server, multiple clients connect to a single server, and they communicate amongst each other with a broadcasting method. So we I have here accept. So this one, what it does is it is a function for the listener that accepts a communication request from the clients. So it will accept a communication link and generate an error. So, and after that we make a client is an object with three things. Basically right now we have only three things. First one is the communication channel where the client is connected, and a client needs to read and write. That is why a client has reader and writer, and both of these are buffer IO. So uh, that is an efficient way to send a message over TCP channels. And we have also used a mutex lock. So uh, I would tell you about it later, but right now you can see that I have maintained a map of clients. Means that we are keeping track of whichever client is connected right now and which have disconnected. So I have not written the disconnection logic, but right now we have a mutex lock that locks the map whenever we are updating any client details. And after that we print some statements, and then we have a go routine. So this will uh, this go routine will run a function that is a handle client. We send the client in here, and everything related to the client will be handled here. So in the main logic, there is a listener, there is a infinite loop that accepts a client, build a client object, update the map of clients, and calls a function handle client in a go routine. Okay, and let's see how what is a handle client function do. So it receives a client object pointer, and here we have a defer similar to the main logic. And defer, we first update a client, that is if the server is done, then we need to delete the client details from the client map. So we lock and delete, and also close the client connection. Okay, and in an infinite loop we receive message and broadcast. So here we have a read string method in the reader bufferio.reader. So in the client we had a reader, then we used the read string method, and this is, you can say, a delimiter. Delimiter is a thing that needs to be provided so that the uh, reader knows when to stop reading or when to close a read string. So in here, if I receive a \n from any client, then a message is complete over there, and from there would be a new message. then we handle the broadcasting principles. So here we first build a message object that is a blank object right now, and we received a JSON message from the client. We convert to message object using a function a method that we have already written above, and then we calls for the broadcast function, and write a message to the client that we have received some message, and we flush is necessary so that the buffer flushes the message towards the client, or else it would just segregate all the messages until and unless we flush the message. So what the broadcast does is simple. uh, it's simple. We first it received a client pointer and a message. Okay, so message it's object, client object and message object, and we did the same thing. We During the broadcast we don't want any client to interfere, such as you have seen during broadcast, if any new clients joins, it might receive the message. So that is why we first log the update of the map, so no new client gets the message right then and there. First, we send the current clients all the messages, and then we connect any other clients. Okay, so we traverse over the map of clients. Okay, if client is the sender, then we skip it and we convert message object to JSON. Any error will be handled here, and we write the message with a \n. Okay, and we flush. So each client gets its message, and we now see what is the message object looks like. So we have a message type, message from, message to, and body, and we have three methods over this object, that is a JSON to message. If we have a JSON that we receive from a client or server, we convert using a Marshall to a uh, message object. Okay, then we have message object to JSON. This converts the message object into JSON using Marshall, json.marshall, and we have another that shows the message. So this, what does this message do is print all the details of the message object. And here is the client object. There is a communication net.com, its type, and what does it do is reads data from the connection. Read can be made to timeout and all those features related to the communication link. And this is a reader, this is a writer, and here we have two variables. One is client's map and another is mutex log. And in client side we have the same message object with same methods, and here is a main entry point. We have a dialer that dials to this TCP IP with port 9000, and we have a connection close differ. If the connection is successful, then we move forward and we make three readers and writers. One is connection reader that would read from the connection, one is connection writer that would write to the connection, and one is a standard input output reader. So this is a OS. You have seen in the terminal that I can write message, suppose hi. So this is the reader, a standard input reader. Okay, and we have a goroutine function that reads string from the server continuously. Okay, whenever server try to broadcast, this coroutine will read the message from the server. So a connection reader read a strings with a delimiter of \n that would stop the string from there, and we make a message blank message object, convert the uh, message JSON into message object, and then we show the message that we have received. Here you have seen whenever I say hi, the uh, you can see here there is a message shown in all other clients, type chat and blank blank and hi. And we have an infinite for loop that reads from the terminal. That is a standard input, so it reads backslash n as well as a delimiter. And we make a message object with type chat and from blank and to blank, and we pass the body as message which we have read. We convert to JSON, and then we write to the communication channel with a backslash n, and then we flush. So overall, you can see that we have used mutex logs and readers, writers, JSON conversion, parser, and type declaration, multiple variable declaration, and all those things we have used here. We are using TCP connection right now, but in future maybe we can use a quick or UDP or all those things. And we have specifically mentioned here the IP and port. In future we could pass the IP and port with the terminal itself while running our client. Okay, so overall this is all for right now, and in the next video I would be able to do much more stuff, and I am planning to separate all those types and function declarations, and I would like to implement a good folder structure for the future. And yeah, that's all I think. And I would share the link of my GitHub repository for this project, so you could uh, uh, learn and make it of your own. And the idea is like this: we can use this to communicate or build a instantaneous server and connect with it, and communicate over a local area network or within some few kilometers, or maybe within college network and all those things. So the implementation is going to be a bit hard from here and now, since I have to implement peer discovery and all those things. So let's see what is in future. And once more I would like to show you the working here. uh, Let me say, who are you, and we received who are you, both the clients. Okay, then see you later. Bye bye.